Oops, that made a little noise. All right, this is just a heads up, Tim and Randy. I'm going to begin the announcements pretty soon.
Yeah.
Are we live, Jerry? Hey, everybody. Good evening, and I guess we're live on YouTube, and we have a couple of guest presenters joining us live on the internet as well. So this is indeed the first meeting of the Madison Astronomical Society for the year 2023. I hope everybody's having a very happy New Year so far and have enjoyed the holiday season. I hope lots of you have recently enjoyed or are enjoying a little bit of vacation and R&R time, rest and relaxation. I've tried to do the best that I can. It's been kind of a nice, mild winter, unfortunately, with lots of cloudy skies so far. Tonight we have kind of a slightly different format than usual. We have two different guest speakers that will be joining us later, and they're not actually with us at Space Place. They are at home and doing presentations remotely. So bear with us. It seems like we should not have any technical glitches with that. I don't have too many announcements. First of all, I wanted to, for those of you who are interested in attending astronomy-related presentations in the Madison area, the planetarium at the Madison Metropolitan School District is going to have a presentation this month called James Webb Space Telescope, Gateway to the Universe. And this presentation is going to be given 2 times on Monday, January 23rd, and 2 times on January 24th. Tuesday, that's a Monday and Tuesday, with times at 6 o'clock and 7:30. And here's what the presentation is going to be about. In this program, we will explore the wonders of the design, build, launching, and bringing online one of the most important new tools of astronomical exploration in our lifetimes. The program will also dive into the amazing things that we have already learned from the first 6 months of the James Webb Space Telescope's operation. And usually with those presentations, they'll also do some sort of tour of the current night sky. If you go online to their website, I think it's mmsd-planetarium.ticketleap.com. You can buy tickets there for $2.50 per person. And those have limited capacity, so hopefully some of the dates and times I already gave you, 1 or 2 of those might be sold out already, or hopefully not. So again, that's coming up on Monday, January 23rd, and Tuesday, January 24th. Next month, we are going to be meeting here, and we're going to have a live speaker from the UW Biochemistry Department named Vastan Raman. And his talk is going to be entitled Understanding Phage Bacterial Interactions in the International Space Station. So I imagine if you ever wondered, especially if the stories about the older, some of the older space stations, and this space station's been in service for a long, long time now, and I can imagine there might be some interesting microbes habitating aboard the space station. So it sounds like we might be able to learn a little something about that.
So he's going to be talking about viruses that are bacteriophages?
I'm not.
Bacteria.
Yeah, I don't understand. I'm not completely understanding of the. Someone's asking if this would also involve viruses. Is that correct?
A virus called a bacteriophage.
Okay. Okay. Yeah, I'm not familiar with the jargon, so I would assume so. So yeah, again, it's about phage bacterial interaction. So yeah, I guess the term phage would refer to viruses, and then bacteria interacting with viruses. So that actually sounds very interesting.
They even thought of bacteriophages as being treatments for bacterial diseases.
Yeah. So, yeah, for those of you who are joining us on YouTube, please be aware it's going to be very difficult, or maybe I'll kind of improvise away since we're kind of doing this format this way for the first time. Right now, there's no way for those of us online hearing members at Space Place who are asking questions, and I'll have to try to do my best to repeat the questions as I understand them. And also, while I'm thinking of it, on that note, later on for our guest presentations tonight, both of our guest presenters are going to go ahead and run through their presentations. Save your questions for the end, and then I'll do my best to hear your question. For those of us who are on here at Space Place, hear your question and repeat your question. Or Terry, if someone asks a question via YouTube, just recite their question for me. All right, so that's coming up. That's our next club meeting on Friday, February 10th, right here at Space Place at 7 p.m. Quick question for anyone that might be here. Do we have anyone here that's not been here before that would like to introduce themselves? I'll be right with you. I just have to, make sure I don't rip away any cords I don't want to rip away. Yeah, what's your name? What's your name?
My name is Rich Adiaga. I'm here to check out the Madison Astronomical Society because I've been interested in astronomy for a long time, and I don't want to just run out and spend money and think I'm going to be successful.
That's a really great idea. So, hey, did you own a telescope of any kind so far?
No, I have not.
So yeah, this is a great place to be, and it's too bad you weren't here last month. We did have a telescope clinic. However, we do have, if you show up at meetings here, you can chat with people about, their recommendations. For those of you who are interested in, maybe doing a telescope purchase for the first time yourselves, show up at a monthly meeting here, ask a member some questions about what their recommendations and preferences are. Or for those of us who are members, we have two membership levels at the non-student. We have a student membership levels that are cheaper, but for the regular membership, we have, $35? I'm so bad at remembering numbers, or is it $30? So you look it up on our website, madisonastro.org. 70, that's the thing is, if you get the $35 membership and you're a member of a household, that membership is good for the entire household. And it's also, and we have also a full observing membership where you have full access to all of the facilities at our remote observing site, which happens to be called Yana Research Station, and I think that's $70. 70. It says 80 on the form online. I don't. That's it. It says no. For those of you listening online, we're not sure what the membership. The way I would verify it is the membership levels are defined in the bylaws, I believe, or maybe not. But anyway, it requires a full vote of the membership. A quorum of the full membership to approve changes, so we'll want to double check that number.
Discussion about pricing. I remember you're
right, but we haven't had an approval from the general membership on that yet, which is required by the bylaws. Yeah. So, but that's one thing. Is if you go down, if for those of us who are new to it and happen to be members, and if you join us at Yana Research Station during observing season, you can go down there, see what types of equipment people are using, see why they like it, see how you like it, and it's just kind of a great idea, a great way to kind of get your feet wet with different types of telescopes. And also, I believe here once a month at UW Space Place, here they do an observing event once a month, or not, weather permitting. Yeah, and the weather hasn't permitted for a long time, but if you go to the UW Space Place website, website, on every third Friday, they, weather permitting, do have public observing, and they use a few different a couple of Schmidt-Cassegrains and a couple of, yeah, they have a couple of Newtonians and Schmidt-Cassegrains, so that's a great way to kind of see how those telescopes work and how you like them. Is there anybody else that's joining us new? I think everybody else I see here is a familiar face, and it was great to meet you again. What was your name again? Rich. So, Rich. It was great to meet you, Rich. Thank you for joining us. And we do have a few minutes to kill. Just, Rich, I'm just curious, do you live in the Madison area then, or?
Yeah, I live in Madison. I've lived in Madison for about 13 years, I guess. So.
Great. It's great to see you here. So, always great to meet new people. Does anybody else have any other observing experiences that they'd like to share with the club? Or I guess no, I'm not. The last month, the skies have just been brutal. Oh, what? Oh, yeah. What?
I bought that 8-inch.
Was it a Schmidt-Cassegrain?
Yeah.
Yeah, that's right.
CPC, and I sent a picture to Celestron, and they say the dent shouldn't affect anything.
Oh, is it a dent? There's a dent like on the side of the telescope, or yeah, because usually if there's I think one of my telescopes has Schmidt-Cassegrains has a dent, a ding or two in it, and yeah, as long as if you take it out, look at it with the star, if you point it at a star like Polaris that doesn't move a lot, and just off focus it so the starlight kind of looks like a donut, and you see how symmetrical that donut shape is, then you know that
That's what I was going to bring up.
Yeah.
It doesn't look symmetrical.
And so the next step would be, because Schmidt-Cassegrains are really better at staying in collimation than Newtonians, but that doesn't mean that if you move it around that the secondary mirror can't get jostled a little bit and get out of collimation. So that would be the next step, is to, I would recommend getting kind of the highest, kind of a, is good seeing, like when you use high magnification and you look at the star and the star dances around a lot. Well, if you use one of your higher powers, say if you were interested in looking at a planet with, seeing every little detail that you can in Jupiter, use an eyepiece like that on a night where the stars like Polaris is not dancing around a lot, and then you could put your telescope into that off focus so you see the donut shape a little bit, and then it's at that point it's easier to do this with either a camera, which is the way I would do it, or if you have two people there, the easiest way to have one person look through the eyepiece, and as you adjust it, see how the symmetry of the donut changes until it gets more symmetrical.
I thought it would be a nice update.
Yeah. So, yeah, and that's great to bring up, and that's another benefit of joining the club is, you go out at YRS and you might be able to have a chat and then have a demo, because a really good way to learn how to collimate a Schmidt-Cassegrain is actually to try collimating a Newtonian, because the mechanics on that secondary mirror, it's a very similar concept as the secondary and primary mirror on a Newtonian. So that's a great way to learn that. All right, I guess it's looking like we're at exactly 7:30, so I would like to introduce tonight's speakers. Give me a moment to resituate myself. All right, we have two presentations tonight. First, I would like to introduce to you Randy Trank. And tonight he's going to, am I pronouncing that correctly, Randy?
Yes, that's correct.
All right. And on the screen you see with us on screen right now, that's Tim. He's going to speak second. Our first presenter is presenting Lucky Imaging on the Moon. And as he says in the synopsis, that this lucky imaging is a phrase used for certain types of astrophotography. So he's going to explain it, how to use lucky imaging on a processing of a lunar photo. just to tell you a little about Randy. Randy became interested in astronomy under the dark skies of Lake Ripley when he was 12 with an Edmund Scientific scope. He loved the Apollo missions. Randy has dabbled in astrophotography for over 50 years, but all this time he has avoided the moon. If you're like me, I avoid the moon when I do astrophotography too. But now he's returning to his lunar roots and wishing he hadn't avoided the moon for so long. Randy also happens to be a member of the Rockford Amateur Astronomers. So I'd like to introduce you to everyone who by the way, is not joining us with a video feed tonight. I'd like to introduce all of you to Randy. Thank you for joining us, Randy.
Okay, thank you. And you can hear me?
Yes, we can hear you. Terry's given us a thumbs up, so all's good. Thank you so much.
Okay. So I'd like to just pass along a hello from my astronomy club, the Rockford Amateur Astronomers. We're an affiliate of the Astronomical League, and the photo that you see is our observatory and our meeting house. And inside that dome is a 10-inch refractor. It has a astrophysics lens on the end of it. And we have public sessions every fourth Saturday. So if anyone would like to come down and look through that scope, you'd be more than welcome. When I was talking to John Rummel, I think we were talking about a 15 or 20-minute presentation, and I've got this time to be about that, so it won't be a long show. And it's strictly a slideshow. I won't be showing any video or anything at this time. So I wanted to start out with Lake Ripley over in Cambridge, not far from you guys. And I want to take you back to an event that occurred about, 60 years ago, a solar eclipse, total solar eclipse that went through northern Canada, and was a partial eclipse all through the United States. And I observed this eclipse. There's me with my mom in the double-headed pinhole projection box, and a few of my siblings. And I don't remember this event actually, but this was probably my first exposure to something astronomy related. This is up at Cambridge in the backyard of our cottage that we had up there at the lake. So my program tonight is about lucky imaging, and I don't know the expertise level of the people that I'm talking to, so I may be preaching to the choir, or maybe I'll help somebody learn a little bit. But what lucky imaging is, as you all know, when you look through the telescope at the moon, especially with high power, you can see the dancing atmosphere, and how seeing plays a big role in what you can, what fine details that you can see on the moon. And in order to get a good sharp photograph, if you were to just try to take one picture of the moon, well, good luck, because the chances are that you're not going to have perfect seeing at that very split second. But if you instead use video and take a long, a 2-minute video, when I shoot the moon with video, I usually do about 2 minutes. And in that 2 minutes time, I get 1,500 or 2,000 pictures, 2,000 frames. And then you can feed that video into software, which I'll show you, and let the software pick out the best 5% of the frames, or the best 10% of the frames, or whatever percentage you want, and stack just those frames. And it's really quite amazing what kind of detail that you can get doing this technique. So here's my simple setup. I just dragged the tripod off my patio. I don't have an observatory of my own. at the back, this is a 9-inch Celestron, and in the back end of the scope, I have a ZWO camera, which is capable of doing the video, and a motorized focuser. And I do all this from my desk inside the house, so all these cords, they just run inside in the house, where I can stay away from the mosquitoes or the freezing cold. So about that camera, here's a close-up. Actually, the camera that I use is a black and white one for the moon. And there's a close-up of the sensor. I mean, it's a tiny sensor, probably only a quarter the size of a postage stamp. And the way that I stick it into the scope was just with a 1.25 inch snout and a IR pass filter. And you might wonder, well, why would I be using an IR pass filter if I'm using a black and white camera? Well, there are reports out there on the web that say that if you view the moon through an IR pass filter, that helps a little bit with the seeing. I haven't done enough testing to know if that's true or not, but that's what I'm trying right now anyway. And there's what the IR pass filter looks like through a flashlight. So these are the programs that I use to do all of this. I use a program called SharpCap to take the video. Then I use a program called AutoStacker to process that video. And AutoStacker will then create a TIFF file. And that TIFF file, I take that into Registax to do some sharpening. And then after that, I might adjust the image a little bit with Photoshop, just to try to make it a little bit more natural if it looks too contrasty or too gaudy. So we'll take a look at a couple of these programs and what they look like. This is the first one. This is called SharpCap. It's a free program, except I buy the professional version. I think it's pretty cheap. It's like $10 or $20 a year, and it gives you some extra features. But when you have SharpCap called up, you connect up to the ZWO camera, and you see the image that the camera is seeing. And then over on the right-hand side, there are a number of things that you can set up for the amount of gain that you want, the exposure, the type of file that you want. And like I say, I mean, I could spend an hour on each of these programs, so I wouldn't have time in this presentation. But if any of you think that, this looks like a kind of a neat process, and if you have any detailed questions, I'm sure John Rummel, he's got my email address, and feel free to write me, and I'll be glad to help you one-on-one with any of this. So this is the program that takes the video. Then after you get the video, then I get into a program called AutoStacker, and this is where the real magic happens. You set up a few things like an image stabilization anchor and alignment points, and you analyze the video to see how many good frames there are. And then you tell the program how many frames you want to stack. And that's this little, if you can see my cursor, there's a little green box with a number 10 in it. So I am telling AutoStacker here that I want to stack 10% of my frames. In other words, I've looked at the analysis and saw that it's probably 10% are good and the rest are no good. So 10% is about the highest I go. Sometimes it's only 5%. But when you consider that you're taking a 2,000 frame video, I mean, that's a lot of frames that you've got that are fairly good. So then after AutoStacker does its magic, you get a file. I have it set up to give me a TIFF file. And here we see the Bay of Rainbows on the moon. And it looks somewhat blurry. This is the raw TIFF file, but actually there's a whole lot of detail hiding away in this picture. And you can ask AutoStacker to create a sharpened file for you, or you can take it into Registax or whatever program you like to try to sharpen it up yourself. But now I will show you the sharpened file that AutoStacker gives with this next picture. So it's just a tremendous difference. All of that information was hiding in that TIFF file. If I go back, you can notice in the bay here that there's a few craters that you can kind of see, but after that sharpening technique, the detail is just amazing. And it's not my skill doing this. This is just all the software that's doing this. So let's go on here. I'll show you now a result of one night. Actually, this was a morning, and it was a morning where I had to go to work, so I did not have time to shoot the whole moon. So I just shot several videos of certain areas. So each of these boxes that you see is a 2-minute video that has been sharpened with those processes that I just told you about. And just so that I don't spend the whole program talking about software, I wanted to do just a little astronomy with you, just to show you some cool things on the moon, and how good this lucky imaging works. If you zoom in on the moon, take a look at how tolerant it is of zooming. I mean, you can just keep zooming and zooming and zooming, and the detail is just fantastic. Here's Clavius down here. This is a big crater on the moon, and right north of Clavius is Tycho. And over to the right of Tycho, this is kind of a neat little area of the moon right here. This crater right here is called Stoffler. And you can tell that Stoffler, the impact that created Stoffler, happened before Tycho, because Tycho's rays are imprinted onto the floor of Stoffler. And then take a look at this crater here. I'm hoping that my cursor is visible. That crater had to have happened after Stoffler, because it punched a big hole in Stoffler's floor. And then there's this bigger crater here that had to happen later, because it wiped out the rim of this crater. And then we have two more craters. This one here, it wiped out the rim of the big one. And then this crater here wiped out the rim of this guy. So this is one of the techniques that the lunar astronomers use to date features on the moon. All they do is look to see what's on top of something else. So it's 1, 2, 3, 4, 5 impact events that occurred in that order. So there's a couple craters that a lot of people are familiar with. Here's Ptolemaeus. And when you look at Ptolemaeus through the eyepiece of a telescope, you're likely to see it something like this, where there's that one big crater on the floor, possibly another crater, but that's pretty much about all you can see unless you have a perfect seeing night, like Tim down in Florida. But if we zoom in, look at the detail that lucky imaging can dig out when it has so many frames to choose from. all these little tiny craters. Just south of Ptolemaeus is I think this is called Alphonsus, and it's got some craters in it that are not impact craters, but are thought to be volcanic vents. And you can see the black stuff that has come out of them. I don't know what it's called, but I'm not, I don't know geology that well. Let's go north again. Over here we got, now this is a little bit too contrasty. I don't usually like to have pictures this contrasty, but this is the Sea of Tranquility right here. And I always recognize where Apollo 11 came down because of this crater right here. It's called, oh, now I'm having a blank. Maybe I'll think of it. But that crater is Moltke. Crater is called Moltke. And it's very visible when the moon is full. It's a bright white splash. And just north of Moltke, there are craters, 1, 2, 3, named Armstrong, Collins, and Aldrin. And these two guys, Armstrong and Aldrin, landed their lunar module right down here, right north of Moltke. So you can see the very first Apollo mission that actually landed was in a pretty safe place without any mountains around. Going north again, here's Archimedes, and if we zoom in right here, we can see Hadley Rill. And this is where Apollo 15 landed. And an interesting thing about Apollo 15 was how they came in to land. They came, they were flying the lunar module in from the right over here, which would be the east. So they were flying this direction, and once they had to get over these high mountains right here, and as soon as they did, they had to make a steep descent because they landed about right here. So that must have been quite a ride for them. And if I zoom way in, you can actually see one of the features where they visited. They landed about here. On one of their lunar excursions, they went over here and explored some of the mountainous area. This is one of the lunar missions where they had the rover so that they could drive pretty far away from their lander. On their second excursion, they went over here and explored the Rill area. And then on the third excursion, they went north. And there's this very faint looking feature right here. I think they actually made it to that hill. And it was a shorter excursion, but I think they made it up there and then came back. So, like was said in the introduction, I grew up with the Apollo mission, so I still think they're neat. They're fun to study. Over here, north of the Sea of Tranquility is the Sea of Serenity. There's an interesting crater in the Sea of Serenity called Linnaeus. Linnaeus is a very small crater, but it has an interesting history. I won't go into it here, but if you want to read a good story about the moon, look up the crater of Linnaeus, L-I-N-N-E. But I also wanted to give you an idea of the resolution that you can get with this lucky imaging with a 9-inch telescope. I know the diameter of Linnaeus is 2.5 kilometers, and I know how far away the moon was on the night that I took these pictures. So it's just a trig calculation to tell me that the angular diameter of Linné was about 1.4 arc seconds, which is pretty darn good. But that's not the smallest thing that you can see in the photo. If we zoom in, there are other craters that are smaller than Linné. There are some of these little white spots that are smaller than Linné. So if Linné is 1.4 arc seconds, I would guess that maybe the resolution of this picture is somewhere around 1 arc second or so. So we'll come back to the resolution in a second, but let's go up and look at a couple other things here. Here's the Alpine Valley, which you can barely see. There's a little like rill that goes through it. You can see it a little bit, but not much. But here's the crater Plato, which is very obvious on the moon. And I always remember the size of Plato because it was the distance from our house when I was a kid to Lake Ripley. It's about 60 miles in diameter. So that's just a quick view of some of the cool features on the moon, things that I like to look at and zoom in on. And I wanted to go back and just mention one thing about the resolution. If I'm getting 1 arc second resolution, there's this thing called Dawes limit, which is a relation that this blue line here is Dawes limit. It's a relation that tells you the expected resolution that you can get based on the size of your objective lens or your objective mirror. Now, there are limitations to Dawes limit, like things that, for example, if you have a central obstruction, like I do on a celestron, or if your optics are not perfect, which mine are probably not, or if your seeing is not perfect, if the atmosphere is too jumpy, those types of things play into whether or not you can reach Dawes limit. I don't think I've ever actually reached Dawes limit, but you can see that for a 9-inch telescope, my theoretical resolution is about 0.5 arc seconds. So I think in that picture that we just looked at, I was up here somewhere, which, I don't know, it ain't bad. It's close to Dawes limit, and so that's that. Let's see, do I have anything else? I think that's basically it, but I demonstrate that just to show you that when you have the choice of being able to pick from 2,000 pictures, you're liable to get some really sharp ones, and then let the software do its magic and see what you can do.
Yeah, Randy, I'd say, especially if you're doing all of your imaging here in the Dane County area, is that right?
Well, I'm in Rockford, so Winnebago
Rockford,
County,
yeah.
just south of you.
So close to where the polar jet stream is all the time. So if you're getting somewhere around, as close as you are to getting the Dawes limit with this jet stream issue that we have, those are amazing results.
You look at the weather maps, and it seems like the jet stream is almost always near us, so it's always jumpy. So here's just a summary of my process. You need a scope with a camera capable of doing video. No clouds. Ha ha ha. Good luck this time of year. You need SharpCap or some other program that's capable of making a video. Take a long enough video to give you at least a few hundred frames. I usually get 1,500 or 2,000 frames in a 2-minute video. Then process the video. I use AutoStacker. There are other programs out there. Then process the resulting image. You can let AutoStacker give you a sharpened image, or Registax, or Photoshop, or whatever. There's no right way to do this. It's just a hobby. We do it for fun. So do what is fun. Oops. And I wanted to mention, like I said before, I'm happy to answer questions one-on-one with anyone if you want to email me. But there are some great videos out there on YouTube about lucky imaging. Sky and Telescope has a few good articles about it. And that's all I have. If there's any questions, I'll take them now.
And I'd just quickly like to say, Randy, I also have your email, so anyone who gets our monthly news announcements, just send a mail to my address and I'll get you in touch with Randy. All right, does anybody have a question? Terry?
They have two.
Okay, Terry's got two questions.
They want to know what program he used for that mosaic stitching.
Yes, one question was, if we can go ahead and ask the first question. Randy, what software did you use to make that marvelous mosaic of the moon's surface?
Okay, that was Photoshop.
Photoshop.
If I were to try to stitch all those photos together myself, it would be a disaster and it would take too long. But Photoshop has a feature called, I think it's called Photo Merge, and you just feed all the individual pictures into it, and it stitches them all together for you.
Great. And then Terry, what was the second question?
The other one was, how successful can you be with a SCT on a go-to alt-azimuth mount?
Okay, they want to know if you've tried doing this fast capture video imaging using an altitude azimuth mount rather than a German equatorial.
No, I've been using a guided equatorial, but you don't have to. You can actually let the moon drift right through your field of view, and AutoStacker, with your process of setting all those alignment points and anchor points, AutoStacker will keep track of where the moon is at. It'll find those points on each image, and it will line everything up for you. So you don't even need a guiding telescope. The only thing is, the moon moves pretty fast, especially under high power, so you wouldn't be able to go 2 minutes, so you wouldn't get 2,000 frames in you might get 100 or so, or 200.
Great. Is there anyone here at the Space Place that has any questions? Oh yes, go ahead.
He had a screen, an image that showed his process right near the end, and I was getting ready to take a picture, and he switched.
Oh, hey, Randy, could you give us go back to the frame that shows you a summary of your whole process? We had a person here who wanted to take just a quick camera picture of that slide with the whole process shown.
It was the summary of his procedure.
Yeah, it was the summary of the procedure.
Oh, the summary?
Yeah.
Oh, okay.
That looks like all of it. Oops. There we go. Hey, he got it. He thanks you. One question that I would have for you, as far as the video camera you're using, what would you say is the minimum frames per second you would like to have?
I don't even look at the frames per second, but
Okay.
Let's see, what if I get, let's see, 2,000 and 120 seconds. So with that black and white camera and such a small sensor, it doesn't have much data to write.
Right.
I'm probably getting about 15 frames per second.
That's pretty
Now,
good.
I am using, the computer that I use has a solid state hard drive, which helps because it speeds things up.
Yeah, because even if you have a camera that has a fast frames per second on it, that might be slowed down a bit by whatever computer you're using. So right. As many frames per second as you can get, the best. But you're having great results with that. 15 frames per second you're having? It looks. Yeah. Yes, someone.
How are you going to know what frames per second to put it at?
How would you know what frames per second to put it at your camera?
I don't set the frames per second.
Yeah.
I set the exposure when
Yeah.
SharpCap has a built-in histogram,
Right.
so you can set the exposure and the gain and all that stuff, and the camera will put out as much as it can based on what it's writing to.
And and if you're like myself, I've done similar imaging using a CMOS camera with my software has a pixel zoom on it, so I can zoom in a small area in a pixel. And yeah, sometimes if you're working with a setup like that, you might have to specify which frame rate you want to work with. But if you're getting a dedicated video camera like this that's built for this purpose, that it'll just do its thing. And you can just keep an eye on it, how many frames you collected within a certain amount of time. But yeah, if you're getting results like Randy here with 15 frames per second, if you're, matching that or, close to that, you get the same results. Oh yes, we got one more question.
I have a comment that said the image of Lenny shown is about the size of the meteor crater in Arizona.
Oh wow, so someone's remarking about the crater, the Lenny crater you showed us, Randy. It's about the same size as that famous crater in Arizona, you were saying?
Oh.
That's very interesting, especially for those of us who've watched some sci-fi movies like Starman or something where they've used that as a location. That's kind of a famous thing. That's really neat to know. I'll have to remember that about Lenny. Did somebody wave their hand for a question? All right, I guess it's a little bit after 8 o'clock and we're out of questions. This is a really great talk, Randy. On behalf of Madison Astronomical Society, thank you so much for sharing with us your time and wisdom tonight. And these shots of the moon are great. And I just thank you for spending so much time on this really neat hobby and sharing your results with us.
All right, very good. Thanks for having me, and I'm going to stick around to watch Tim's stock, so I'll get out of my share here.
All right. Tim, are you with us?
Yes.
Oh, can we hear him? Oh.
Can you see it?
Oh, yeah, we can see you and hear you. I'm just going to go ahead and introduce you. All right. Now we're going to have our second presentation. And joining us tonight is Tim Wilson, and he's going to present data collection, organization, and pre-processing with respect to astrophotography. And just to tell you a little about Tim, Tim is a retired CNC manual machinist, and he retired in 2016 from the Savannah Company in Waunakee, Wisconsin. Tim has done visual astronomy for the last 40 years, but finally tried his hand at astrophotography in 2014 and has been doing it ever since. Some of his other interests include electronics, 3D printing, CNC routing, carbon dioxide laser cutting, and guitar. His love of science and technology, he has love of science and technology and enjoyed reading books on physics and astronomy. Tim is a longtime member of Madison Astronomical Society. So thank you for joining us, Tim.
Well, thanks for having me. I appreciate John asking me to do it, and when he did, I kind of jumped at the opportunity, and I really enjoyed Randy's talk. That was fascinating, really. Those pictures of the moon. Astronomy, astrophotography is a big topic, and the little bit that I want to talk tonight about is just to gather some of the data and how you do that to put an image together. Now, the image I have up there is one I took, and that's about, I think there was 55 frames. That's the Andromeda Galaxy. And how I did that was here, I'll show you here. I went and set up my camera. Let me see if I can get this pulled back up here, guys. All right, there we go. That's what I was looking for. And I took these frames here. In order to get an image like that, you're going to have to collect these, and then you're going to have to stack them, and you're going to need a software to stack them. You also need software to capture them with, and that would be a whole presentation in itself. So what I did do is I'm putting the finishing touches on a YouTube video that will show how to. I show the whole process. I'm trying to get it down to about 35 minutes. It's quite long right now, but I'll make sure that Lawrence gets a link to that, and maybe can attach that to the YouTube video that's going to go with that. But I use Astrophotography tool, this right here, this app, and that's not a freeware, but it's fairly cheap. I mean, I paid, I think, $40 for it. I believe that was the going rate for it. And then you'll need something once you collect all this data. You're going to need your dark files, and you're going to need your bias and your flats and your lights. So I went and took my light frames here, and then you can see on here, it tells you set like how much your binning will be, and then how many seconds it'll be, and then how cold it's going to be. And then I got a FITS viewer, because it'll put those files, and I can check these then. I can just toggle through and see what ones are good and what ones are bad, and then I can kind of kick the ones that are bad to the curb. But even when you do that, and that's the nice thing about stacking software, and I'll show you as we get into that a little bit, it allows you to see maybe if a scope is bumped, or maybe you have a star that's out around. So what I'll show you when we get there is that you will actually score these. You're going to register them before you stack them, and then score them. And like in these dark frames here, you can see I got the same exposure time. You got to have the same exposure and binning and the same temperature. So organization is everything. I think that you want to make sure that when you start your imaging session, that you create a folder first, and then create a dark file folder and a bias folder, the flats and the lights, and then they're easy to access. And with that, I will take, and I have Deep Sky Stacker here. And one thing about Deep Sky Stacker is it is just for Windows users. A lot of people will get something, and you can run it on a Mac if you run a seat of Windows on there. And after seeing Randy's presentation, I'm not sure that AutoStacker does something very similar to this, and it may be compatible with Mac. So that's something to keep in mind. This is a freeware though, and it's a very popular one, especially for what I'm doing here with that image. It was a one-shot color camera, and if you have a DSLR, and that's what I started out with. A lot of people start out with a DSLR and a small refractor, and it works great for that and a one-shot color. Now I do have a bigger scope, and I have a monochrome camera and a filter wheel on it, and I do processing with that in PixInsight. But for my one-shot color, I just don't think you can beat this, and it's a good place to start. And I'll go over some of the things you would do here. You see these red highlighted ones are the ones you pay the most attention to here. Like open your picture files. We'll go and grab those files, these light plant files here, and then I'm going to just stick those in there, and we'll open them up. And then what you want to do is come down, and you will go to your settings, and oops. And you are going to go to your FITS files. You want to make sure that, and I do this in the 16-bit because it's easier to manage, match up your camera to here. Make sure that, like you have that DSLR, make sure that this is clicked here. And there we go. Okay. We're going to check all these, and then we are going to register these checked pictures, but we do not want to stack them at this time. And I'll show you, we'll do this very quickly. This computer's pretty fast. But let's see. And this recommended, it will give you the recommended values as well on that. So this will take just a second to chew away on that. Then after this scores these, I'm going to point out up here. Let's see if I can get that down.
Tim, mind if I ask you a quick question?
Yes,
Now,
go ahead.
Now, at this point, now, none of these images that you're stacked, these unstacked images, none of these have been processed in any way yet?
Not yet.
These
No,
are all raw files?
These are all raw files, and then we're going to create a TIFF file with them. So you can see what we're doing here. Here's the scores. And I looked at these, and I got these are all in the 300 and 400s. But here's one that's 251, and you'll see the difference. Even though the file, and then there's the slider up here, and you can tweak this back and forth. But I take it, and you can stretch this image, because if you just take it where it's back, you can see that you might not be able to see anything with this. So you want to stretch this file so you can see it. There we go. And then I can see the stars up in this corner, and I can see that that looks pretty round. But now I'm going to go and take, and I'm going to put this one up here with 251 for a score, and I'm going to check it and look at that stars oblong on there. So while it may not look like much, when you put it up here, you might not see the difference. Go ahead and pull one of those up in that window. And so what I do then is I'll take and I'll kick that one to the curb. I'll get that out of there. So, oops. So then it would be, we'll take that and get that, we'll uncheck these. And I made a movie of this. We'll remove that. Yeah. Okay, now I'll add the dark files. And then we add our flats. And I'll tell you, if there's, I used to just do darks and lights, and that's all I did. And I didn't see the value in the flat files. And I sure wish I'd have done them years ago. And then our bias files. Oops.
And quick question, go ahead.
Go ahead.
By flat files, what do you mean exactly by flat files?
So on the flat files, what you do, I'll go over these kind of individual. Light files are just the ones that you take of the image where you set up your polar alignment on your scope, and then you're tracking, and you get the scope all calibrated and stuff, and set up your auto guider and stuff. And then with the light files, they're going to need some what you call calibration frames. So on these calibration frames, we want to remove things like amp glow in there. So let's go take a second and look at like the darks and the lights and see just what they look like. Let's see if we can get out of there. And you can see, and it's kind of shocking really, that how much garbage is in there. Now you can see there's that amp glow in this. This is with an ASI one-shot color. It's a 294 MC Pro. And you will get some amp glow. It's a great little camera, but it's not like some of the more expensive ones. Even my ASI 1600, the monochrome camera, I don't get amp glow like that. But what I think was more shocking to me was when I took my flat files. And I thought, well, you know, you want to get rid of the dust bunnies and motes and stuff on your sensors or something like that. And I thought, how much am I really going to remove? So when I pulled one of those up and I saw this, and I went, okay, that's what was going into my image. So that was just the value of taking these flat files. And the beauty of taking these flat files and putting them all together and stuff, it was so simple. On Astrophotography tool, and I think in Sequence Generator Pro, what they have is they have on that software, they have a tool where you can, well, I'll back up a little bit here. To do the flats, you want to make sure that you set your scope up and it's you leave it focused like it was through your imaging session. And I do the white t-shirt. Some people will take like an iPad or that and lay that on top of the white screen. Well, what I do is I set it up in my garage and I have an LED light and I will send this underneath there and I'll put on this white t-shirt and stretch that over there. And then I'll let the software do the work. Instead of trying to get the light value just right, what that does is it measures a thing called the ADU, and I'll set it between maybe 20 and 30,000 on this ADU value. And then what I'll do is once I click it to automatically check it, and what it does is it measures it. It has a histogram, and it'll measure the amount of light it gets in there, and it gets it just perfect for me. And then it'll set that up so you can run that then, and then you can set that up. You go over to the Astrophotography tool, and it will take however many you set. Say you want 20 flats, it'll do the 20 flats. So that, and then the bias is just checking more of the electronic noise. You only set those up for maybe like a second, and I take 20 of them. But here we go. And so I have all these together now, and then we'll check all these, and then I will register the stack picks, and now stack after registering. This is what you want to see. And you could set this down to like 80% or 90%, and it will get rid of some of the pictures that are the worst. But I've noticed that it takes a little more time, but by making that little window and going in there and checking those individual stars, I've had better luck. At least I think I have with it. And you can go to these recommended settings here. And to me, green means go. If you've got green all through there, those are the recommended settings. That's just what I'm going to use. And I was trying to get, there we go. Yeah. Now that'll chew away on that for a while. The other thing is on these settings, you can go in here and you can, again, this is in the video, you can check that settings to see how many stars it's going to detect. For the longest time, I would do Deep Sky Stacker here, and it would try and see so many stars, and it took me forever to figure out that you don't need to see that many. So I set the value at like 10% on there, and then it stacks it just so much quicker. And otherwise, it's going to take forever. And if you've ever used this software, you know just what I'm talking about. And what it does then, once I get my TIFF file from there, then I'll use a program called PixInsight, and that will allow me to go in, and I'll open that up. And then you can see, you can stretch this, you can expand it. And this PixInsight, it's great software. I do a lot of stacking with it for my monochrome camera. It has a big learning curve. You know, I won't lie, it's a big learning curve. You know, it's you're better off to, it's a big elephant to eat it a bite at a time. If you're just getting into this and you're a beginner, I think it's a good place to start is maybe a DSLR or a one-shot color camera, and maybe get a smaller refractor scope. I just got a 71 millimeter, and then I have a 127 millimeter. And the smaller ones, they're easier to use. I got a triplet. Well, the one I just got, the Red Cat 71, is 4 lenses. But so let's see if we got our image here yet. It's still stacking. But anyhow, I could probably pull open. Let's see if we got. I could just pull open a single frame here. And you can see on that, you can't really see anything. And so I come over here, explode that, and then you can see the detail with it. This is where you're going to take that finished file that comes out of Deep Sky Stacker, and you'll process it there. And then what we ended up with was the image that you see right there. And I did have a hydrogen alpha filter on there as well to pick up some of that. So I guess that's just about all I had on the stacking of that, and I'd be happy to take any questions.
Yeah, do we have any questions off the
I
bat?
don't have a question yet, but there was a comment about there's Astropixel processor will give a graph of star analysis, great way to see the outlier frames, or if your data is deteriorating over the night.
Can everybody hear me over the PA here? I don't know if I have the mute on. Sorry to. Okay, because I guess somebody joining us from YouTube is mentioning that there is software out there you can use to inspect individual frames for how sharp your stars are. And could you repeat that? Astropixel processor. Now, yeah. So
okay.
And I don't know if that's available for Mac or PC, and some of these other pricier astro imaging software will have similar features like CCD inspector and things like that I've heard of.
Yeah, I try and do as much inspection too. Yep.
But if you do just what he did, I like the feature on there where it scored them, and then you can just zoom in and you can see what your star shape is, like you saw the symmetry, or you could compare from frame to frame too and see how much sharper some of your frames are as far as your stars. Any questions here at the audience here at Space Place? Anyone? Yeah, one of the things I noticed, sometimes if you're imaging and you're really kind of stretching what we call your imaging circle, one of the things I noticed about not doing my flat frames is I could not stretch my images out, like you have in your finished file there, like when you showed where the image was dark and then you did a power stretch where you could pull out all the images. And I found I could not amp up my images high enough unless I did a flat frame. Have you had any experiences like that, like say when you have vignetting in your imaging train?
No, not so much. I guess I've been using it. If I did it, I don't remember it, Lawrence. I've been using these flats now for a long time. But I do remember when I got started that very first year and I didn't use them. I had so many issues, and I just couldn't get rid of all the junk in the image, you know. And it's a game changer, it really is. And you talk to a lot of people, and that's what they'll say is that, I didn't take flats either. I just didn't see the value in them, and it's worth any time you invest in it.
I agree. I agree totally. I remember seeing your flat frame. It didn't look like, and when I say vignetting, for those of us who are new to the hobby, it's when you get an image where in the center of the image it's a lot brighter, and the further away from the center you get, it gets darker, and that's because your imaging chip is slightly bigger than the imaging circle that you would see through your eyepiece, and that would, if your camera was an eyepiece instead. So if your imaging chip is so big that it gets out of that imaging circle, you'll get vignetting, and which if you're using like I'm used to using an 11-inch Schmidt cassette grain with a CMOS, a regular DCLR imaging chip, and I have to deal with vignetting all the time, and the flat frames are absolutely essential.
Yeah. So I could open up that, if anybody wanted to see it, I could open up that, maybe in PixInsight, that TIFF file that I just did with that stacking. Let's see it. There it is. It makes an autosave. And then you can see this is the image. And it's green like there. But you can delink that, and that maybe I should do that.
Yeah, and if you're, a lot of us deal with light pollution and things in our images. So yeah, you can get tinning like that.
Let's get that.
And that's one of the great things about PixInsight. Do you use the color calibrator with PixInsight there?
Yeah, the auto. I think I have that. Maybe not on this computer. Let's see.
Color.
So,
yeah, I see color calibration there. Yeah.
So let's use screen transfer function, and then what I do is I'll hit that radioactive link. But then you hit this link up here, and can we set that?
Yeah, and he's hitting.
There we go.
There, that hit
So,
function. Yeah. There
yeah.
you go.
So then you can see this is before I did any processing. So it comes out of autos or Deep Sky Stacker, and you can see that amp glow that was over here. You still got to get the color right, and you've got a lot of noise in there that you're going to want to denoise and all that stuff to it. But it's still it gives you a good jump on it right there.
Yeah, that's a nice looking. It's a great looking image there.
Yeah, thanks.
What type of telescope do you like using?
Well, I use an Explorer Scientific 127 with for my monochrome camera, and ZWO 1600, and then I bought, and I got it down here in Florida now, and I just absolutely love is a Red Cat 71. So I've taken a bunch of pictures with that, and have just been amazed. I don't even use a field flattener with it. It has the 4 lenses, and I don't get any vignetting or anything with it. And it's just been taking beautiful images, and it's so light to pick up. And I was able to go to a much smaller mount. I went with the Skywatcher 35. That's a very light mount, and I can pick it all up. And old guy that I am, and walk it out to my front patio here and shoot away.
Yeah, that's the great thing about imaging with a small refractor. And then every night, so almost every night, as long as you got good transparency, every night's a good seeing night with a small refractor.
Yeah, and like if you want to do the Orion Nebula or something, you can get the whole Running Man. You can get everything in there. So, and like I say, I will get you that link to attach to that, and the other videos that actually do explain in a lot greater detail of how to capture that, all your darks, lights, and flats. And I go over some of the things on there. I might break that video down into different sections, so if there's something somebody doesn't want to see, but right now it's pretty lengthy. So,
yeah, it's always good to have something that people can kind of go in greater detail and see each step along the way. So yeah, I'll be sure if you get that link to me, I'll be sure to get it to Terry. Terry, if you think we could put that in part of the description of we'll put when we put up this month's broadcast on our YouTube page. So, well, great. Thank you so much. Thank you so much, Tim. It was a very excellent presentation. I can tell by people's reaction. There's people here taking notes, and
right, thank you.
we're really ready to sink their teeth into this astrophotography hobby. It's a great hobby, and yeah, thanks so much for introducing our members to this.
Yeah,
Great-
thanks so
great
much for the
presentation,
invite.
yeah.
I appreciate it. Thank you.
All right, well, thanks for joining us, everyone. And just before we go, I'd like to remind everyone that we will be meeting again on Friday, February 10th, where we will be learning about phage and bacterial interactions on the International Space Station, and we'll be here at 7 o'clock. And this concludes the January meeting of the Madison Astronomical Society. Good night, everyone. Good night, Tim. Good night.
Night.
Good night. Now I'm having brain freeze. Good night, Randy.
Thanks, Frank.
Yep, okay, thanks.